All right, so I think this is the last exercise as part of chapter 6. And it's actually doing a graph that's slightly different to the cubics that we have been doing before, because this is now to the power of 4. So we're looking at graphs that have x to the power of 4. Now, we haven't looked at that kind of thing yet. So what I want you guys to do, as it says here, is sketch that on your CAS. I want you to sketch that and see what it actually looks like. Once you've sketched that one, I want you to sketch that on the same axis. So I want you to see what they both look like so you get a little bit of an idea of the graphs that you're going to be sketching. Right, so I'm going to do it now anyway, but please pause and have a go yourself. So what you'll see is this graph, when you sketch it, it's going to look a lot like a parabola, except instead of being more thin at the bottom, it's going to be real like fat at the bottom. It's going to have like a bucket shape like that. It's probably a bit too low. I might fix that up. Yeah, something more so like that. So they are quite similar to parabolas. And you might be able to notice when you sketch this next one, this one here, that looks like turning point form, doesn't it? Except instead of a 2 here, we've got a 4. So if you can see that you've got a 4 there, it's not going to be a skinny sort of parabola. It's going to be that fat bucket-shaped quartic graph, is what they say when it's to the power of 4. Now, we've seen this kind of thing before, so we've got our general rule and then tells you what the different letters actually do when we change them. So we could see that it was super similar to a parabola. So all the things do the exact same thing. It's just that the shape is slightly different in terms of being fatter at the bottom, as I showed you just before. So I think we're going to be able to draw this kind of thing really, really quickly because we've practiced it so many times before in the past. So if I look at this one, the first thing I want to be able to do is find out what the turning point is. So the turning point, hopefully we can see that instead of -2, the x value is going to be 2, and then our y is -16. There's our turning point there. Now, there's no negative out the front here, there's no negative in front of x, so the tail is going to be pointing up. So we should have, if we go 2 and -16, this isn't perfectly to scale, but that's okay. Our graph should have a shape of something like that. Doesn't have to be absolutely perfect, but that'll do. Okay, now we can see that we've got a y-intercept and we've got 2 x-intercepts. We're going to have to be able to find out what those are to show them on our graph. So let's find the y-intercept first because there's only one of those. And we make x equals 0. Alright, so we've got -2 to the power of 4. So that means -2 times -2 times -2 times -2. Okay, so -2 times -2 is 4 times -2 is -8 times -2 is 16. Yeah, 16 minus 16 is 0, so I have made a bit of a mistake. So I probably should have done that before, shouldn't I? So -16 minus 16 equals 0, so therefore our y-intercept is 0. As you can see, when I drew the graph, it looks different to that, doesn't it? So it's probably a better idea if we work out what all those key points are first. So I might get rid of this one. I'll work out what the x-intercepts are first though. So that's a problem that we can get into if we don't work out those points first. And we want the x-intercepts. We can already see that one of the x-intercepts is going to be 0 because of this point here. But there's going to be another one as well. So let's find out what that one is. Let's make y equals 0. Alright, now to get rid of that to the power of 4, we'd have to do, I don't know the real name for it, but 4 root and a 4 root here as well. So what number multiplied by itself 4 times gives you 16? The answer to that is 2. So we've got 2 equals, it's going to be plus minus 2 actually. Because remember when you put a square root, you need the plus and the minus of it. So we need to make sure we're putting in the plus and the minus of that one there as well. There we go. So let's just look at the positive one first. So we've got x, we've got a plus 2 on the other side, so x equals 4. Now if we look at the negative of it, that's going to be x equals 0, as we found out a little bit earlier. Alright, so let me get rid of this dodgy graph that I drew before, and then we'll fix it up. Alright, let's do a better job of putting those points in. So I have my turning point at 2 and minus 16. Let's say it's here. I have an x-intercept at 4 and I have an x-intercept at 0. The y-intercept is also at 0. So there's that spot. X and y-intercept, and 4 would be somewhere around here. There we go. Let's make sure we get that nice kind of buckety shape at the bottom as well. There we go. So that's a little bit better. Cool, let's move on to the next one. Now, just as cubic graphs, they could look a couple of different ways. So a cubic graph, we worked out that you can have your point of inflection one that looks like that, but you can also have one that looks like that. We've now got 4 factors, 1, 2, 3, 4. If you multiply all those together, your polynomial is going to have like a highest power of x to the power of 4, and they're actually going to look a little bit different to these. As we saw before, when we have a quartic graph, put that in brackets 3 because it's to the power of 3. I'll put in brackets here 4 because it's to the power of 4. A quartic graph, we saw that we have those kind of parabola bucket type shapes. But you can also have this. So instead of just the 2 turning points, you're getting an extra one. So you've now got 1, 2, 3. It looks like a bit of an M, doesn't it? And it can also go the other way around, just as these ones can, just as cubics can look like that. Instead of an M, the quartic can also look like a W as well. There we go. So one of these, or this, shows us where all the quartic graph's x-intercepts are. If we expand it out, your x to the power of 4 is going to have a positive coefficient. So that means the tail is going to be pointing upwards. So it's probably going to look like this one here. Let's start sketching this graph and show where all those x-intercepts are. We have an x-intercept at 1. We have one at -2. We have one at 3. And we have one at -4. Cool. And we also know, because if we expand this out, it's going to be a positive coefficient of x to the power of 4. The tail is going to be pointing up like this one. So the graph will look like that. We don't need to show where these turning points are. We don't need that one just yet. We'd almost be done here. There's one thing that I've forgotten about, which is the y-intercept. We need to show where that is. So to find the y-intercept, you make x equals 0, as you know. Okay, 1 times 2 times 3 is 6 times 4 is 24. There we go, we are done. Let's have a go at another one of those. Alright, now we can see that this one actually has 4 factors as well, because there's 2 here, there's 1 there and 1 there. So you could also write this one as x minus 5. Because it's squared, there's another x minus 5. Okay, so it shows where our x-intercepts are. We're going to have 1 at 5, -1, and -3. But this one, you guessed it, there's a square there, so that turning point is going to, that x-intercept is going to be a turning point as well. We've got a negative out the front. If we expand this whole thing, our coefficient of x to the power of 4 is going to be negative, so the tail is going to point down. Firstly, let's show all those x-intercepts though. Alright, so at 5, -1, we have -3 as well. Okay, now we worked out before that the tail is going to point down, so let's start there. And also the turning point is going to be on this x-intercept, here. So the tail is going to start down, but as soon as it hits here, it has to come back down. Then we need to go through the others as well. Here we go. So we've accounted for all those x-intercepts. We have the curve bouncing off that one, turning point on the x-intercept. The only other thing we need to show now is this y-intercept here. So same as before, make x equal 0. I'm just going to change this to a -1. So it looks like minus 75 is our y-intercept. There we go, that one's finished as well. Alright, so you're going to have a couple of questions like this inside this exercise here. We want to solve for x. So normally when we're solving for x, we're trying to factorize as well, which is pretty much what we're going to be doing here, except they're going to look slightly different. With this one here, we're solving for x because it's the only unknown there, and we have been told to do that. But let's work out if there's any common factors first. I can see that there's x to the power of 1, 2, 3, 4 here, x to the power of 3 here. So we can actually take out x to the power of 3, which will give us x minus 6 equals 0. So what we have now is x to the power of 3 equals 0 and x minus 6 equals 0. So x to the power of 3 equals 0, x has got to be 3, x has got to be 0, and x minus 6 equals 0, x is 6. There we go. So it's important to have a look and see if you've got any common factors first. Now this next one, let's just look at these separately for now. Can you see how there's something squared minus something else that could be squared as well? You've got a couple of difference of 2 squares here. So there's one dot's there and there's another one there. So we can factorize these kind of separately. So if we factorize this bit but alone, it would be x plus 2 x minus 2 using our difference of two squares rule. So that's that section. I'm going to put that in square brackets so you can see that that has turned into that. We can do the same thing with this section here. So again, I'll put that in square as well. This is going to become x minus 3 or plus 3. X minus 3. There we go. So we've now factorized those two sections. So we don't actually need these square brackets. I've only used those to show you where I got all of it from. So you can just write it as this. And we were solving for x, weren't we? So we're fully factorized. We should be able to work out what our values of x are. So we've got x equals negative 2, x equals 2, x equals negative 3, and x equals 3. And we're done. Okay, last part. Now this can be a little bit difficult. I can't remember exactly if they have these sort of questions in the exercise. I think maybe, but I'm not really sure. I think it's more so extension sort of stuff. But you might need it anyway, so have a look. Alright, so we've got a couple of rules here. We've got one called f of x and we've got one called g of x as well. Hopefully we can remember what these sort of things look like. Okay, so here's our sort of real bucket parabola sort of shape. And then we've got our point of inflection, but it's got a 2 in front, so it's made it a little bit skinnier as well. So let's try to sketch these ones. And remember, they haven't been moved up or down, left or right either. So their turning point and their point of inflection, they're both going to be on 0, 0. Alright, now I might do this one in black. And I'll do this one in blue, just so we know the difference. So it looks something like that. And it has its turning point at 0, 0. So I'm going to make that a bit thinner. There you go, something like that. Now our other one is going to look something like this. It'll come down and then, this one's really dodgy, but it should go something like that. Actually, I'm going to start this whole thing again because that looks like crap. I just want to try and be neat, that's all, rather than giving you a real messy looking thing. Alright, so that one should look something like that. That's our one with the point of inflection. Point of inflection at 0, 0. And our parabola, it's not actually a parabola, it just looks like it, I keep on saying that. Should be something like that. Now, it's a good idea if you guys sketch both of these in your CAS just to make sure they're in the right spot. But that should be it. I know it looks a little bit wonky, but that's the general kind of shape that you're going to have. Now, the next part has told us to solve the equation f of x equals g of x. So they've tried to... They're making us have this equals that. Alright, so I'm going to set that up. Right, and it wants us to solve. Now, x is the only thing in there, so they must be asking us to solve for x. Let's move this 2x to the power 3 to the other side. So now what we have here, that looks pretty similar to that question that we did up here, doesn't it? So we're going to be able to solve that in the same way. Okay, so we can see we've got x to the power 3 is common to both. So we've got x equals 0 and x equals 2. Now, let's have a look at what this actually means. We're finding where f of x is equal to g of x. So that means where those lines are actually going to touch together. So we can see that from our picture here, we've got their lines touching together here, and the lines touching together here as well. And we've worked out that the x values where they touch together is x is 0, looks like that one, and where x is 2 must be that one there. Okay, so that means the x value there is 2. So if we had a coordinate, we'd have x being 2 there. I don't know exactly what the y value is. They haven't asked us to find it. I'm not going to find it. Now, this next part, we did inequalities not too long ago. It says solve the inequality f of x is less than or equal to g of x. Let's look here, where f of x is less than or equal to g of x. Now f of x is this one. And I think I've perhaps marked this up. I think if you look on your cards, I'm going to check pretty soon, I think that's supposed to actually be like that. That's supposed to be like that. And that is supposed to be the blue one. Yeah, check on your cards just to make sure that's right, but we need to make sure the correct one's on top, because it's asking us here which one's higher than the other one, or less, which one's greater than the other one, or less than, sorry. So we can see that we want to know where f of x, which is this black one, the quartic, is less than g of x. Okay, so where's the black one lower than the blue one? It's not lower there, not lower there, not lower there. It's equal there. There's only this section where it's lower, isn't it? So the answer would be f of x is less than g of x, where x is a certain few values. So it looks like it's lower between where x is 0 and that other point here that we worked out, that where x is 2. So, and also this is equal to, so if it's equal to, we need to have those square brackets, so between 0 and 2. So we're saying that when x is between 0 and 2, between 0 and 2, f of x is less than or equal to g of x, which is that one. So in this section, it's saying that it's lower, which is correct. Now that last one was a little bit messy because I was having trouble working out and drawing a nice clear graph, working out which was higher than the other one, which is why I want you to make sure you check on your CAS to make sure the correct one is higher in that specific area, but hopefully you catch the drift with that one. If I've made it a little bit hard and you need extra help, let me know and I'll try and fix that up, but hopefully that is enough just for now anyway. Thank you guys, see ya.